Finding the derivative of sine x from the limit definition. First of all, some notation. For the derivative, d on dx is commonly used, or d of f on d of x, or f dash x, or y dash x. Definition of derivative of y is equal to function x. So let's have a look at what the definition is. F dash of x is equal to, the limit is h tends to 0 of f of x plus h minus f of x divided by h. What does that mean? Well, if we look at the little diagram here, we've got a set of axes, and we can see we have a purple curve. If we want to find the slope of the curve at the point x, we could consider first of all the second line, that blue line which cuts through the curve at 2 points, at x and at x plus h. So the gap from x to x plus h is of course h. If h reduces to 0, that second point where the blue line cuts the purple curve, that slowly runs back to the point x, and at that point the blue second line approaches the tangent to the purple curve at the point x. Hence the definition. The limit is h tends to 0 of f of x plus h minus f of x divided by h. F dash of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Now that's equal to the limit as h approaches 0 of sine of x plus h minus sine of x over h. Expanding on that formula, sine of x plus h is equal to sine of x times cos of h plus cos of x times sine of h. So we have that minus sine of x all over h. Now I'm going to abbreviate here, so instead of sine and cos I'll use s and c. So we have the limit as h approaches 0 of sine of x cos of h plus cos of x times sine of h minus sine of x all over h. That's equal to, by rearranging, minus sine of x, we'll bring that term first, plus sine of x times cos of h plus cos of x times sine of h. Now we'll split that into two parts. The first part will be the left-hand side and middle term, and the second part will be the right-hand side. So we get limit as h approaches 0 of minus sine of x plus sine of x cos h over h on the left, and the limit as h approaches 0 of cos of x plus sine of h over h on the right-hand side. So continuing from the previous slide, on the left we have the limit of minus sine of x plus sine of x times cos of h over h. And on the right hand side, the limit of cos of x times sine of h over h. Factoring out minus sine of x on the left hand side, because we're looking at the limit of h, so minus sine of x becomes like a constant, minus sine of x times the limit into 1 minus cos of h over h. That's the left-hand side. Let's look at the right-hand side. Plus cos of x, we're factoring that out into the limit of sine of h on h. Now, from a previous video I uploaded, we can see that the limit of sine of x over x, or sine of theta over theta, or sine of h over h as h, or as x, or as theta tends to 0, is simply equal to 1. So that right-hand side is cos of x times 1, which gives cos of x. Going back to the left-hand side, 1 minus cos of h over h. That can be replaced with 2 times sine squared h over 2 by trig identities over h. If we halve the numerator and we halve the denominator, we get sine squared h over 2 over h over 2. We have a form that we can work with that looks similar to the right-hand side. Continuing with the left-hand side, the limit of sine squared h over 2 over h over 2. Well, we've got sine of h over 2 multiplied by sine of h over 2 in the numerator. So let's split that up. That's the limit of sine h over 2 times, because the limit of a product is the product of the limits, the limit of sine h over 2 over h over 2. Well, we know the right-hand side is equal to 1 and the left-hand side is equal to 0. The product of 0 and 1 is 0. So this brings us back to the previous slide where we had the left-hand side, the limit of minus sine of x times 1 minus cos of h over h. All of that worked out to be 0. So all we're left with was the right-hand side, which gave us cos x into the limit of sine h on h, which is just cos of x. Hence, the derivative of sine of x from first principles is cos of x. So to reiterate, f dash of x is equal to the limit as h tends to 0 of sine of x plus h minus sine of x over h, which produces cos of x.